Hello, all my dear students. Last time we had seen how we can convert the binary number into the hexadecimal and hexadecimal into the binary. Now it's done how we can convert the hexadecimal number into the decimal one and the decimal number into the hexadecimal. Okay. So first of all we see the decimal to hexadecimal conversion. But I like to recall one process that we have seen already, and that process is the decimal to binary conversion. In decimal to binary conversion, what we do, we use the method. That method is we call as double table method. That method is double double method, and in this double double method what we do, we multiply the given fractional part and we divide the given integer part. This method is the double double method. In this method we divide by 2 and we multiply by 2. Means for conversion of the decimal number into the binary, we use this method. That method is we call as double double method. All of you know how we can convert the decimal number into the binary by using the double double method. Here we have to convert the decimal number into the hexadecimal. We are going to convert the decimal number into the hexadecimal. So what process we have to follow? We have to follow very simple process, same as that of the decimal to binary conversion. But here one thing, instead of using the double double method, what we use? We use here hexadecimal method. That method is we call hexadecimal method. The meaning of double means to divide and to multiply. But here, instead of the double means 2, we divide by 16 as well as we multiply by 16. We divide the integer number by 16 and we multiply the fractional decimal number by 16. Okay, so let us see how we convert step by step the decimal number into the hexadecimal. Conversion we divide in the two parts. First part is for integer part and second part is for the fractional part. In integer part we divide by 16 and in fractional part we multiply by 16. So very simple steps are there and all of you know the same conversion, which is the decimal into the binary. The same steps we have to follow. So here the first part we see and then we see the second part, that is for the fractional part. Okay. So here are only 3 to 4 steps to convert the integer decimal number into the hexadecimal one. So first step comes, and that first step is we have to write down the given decimal number. We write down the given decimal number. While solving the example, you have to make 3 columns, and these 3 columns are for division, then result, and then remainder. Okay. So first step is to write down the given decimal number. Then we divide the given decimal number by 16. We write down the result and record the remainder here. Now the result we get. The result we again divide by 16 till we get the result becomes equals to 0. Means first step is we divide the given number. So here the the first column comes and that first column is the division. The second one is the result here. Here we record, we write down the result, and after that here we record the remainder. Instead of making the lines here, the vertical lines, we just write down division, then result, and then remainder. Okay, so very simple steps are there, and here just you have to make some calculation, because here instead of dividing by 16, what we are going to do, we are going to divide it by 16. Instead of 2, we divide it by 16. So we must know the table of 16 for that. Okay, now again we recall the various steps for the conversion. The first step is write down the given decimal number. We write down the given decimal number. Second step comes, and that second step is we divide the given decimal number by 16. We divide the given decimal number by 16. Then third step is we divide the result by 16 until we get the result becomes equals to 0. Then first we divide the given number by 16. Then we write down the result and we record the remainder. The third step comes, and that third step is we write down, write down the result and we divide the result by 16 again until we get the result becomes equals to 0. After each division, we have to record the remainder. Now, like in the decimal to binary conversion, in double method, we take the remainders as the answer. Here again, we have to take the remainders in the reverse order. But one care we have to do here, and that is the remainders we get. The remainders are less than 16. Means remainder may be 15, it may be 14, it may be 10, it may be 8, it may be 9. So when we get the remainder as 15, what we write down equivalent of 15 in hexadecimal? That 15 is equals to F. When we get the remainder is 14, what we write down? We write down it is equals to, we have to convert the 6, 7, 8 base 10 means it is in decimal, and here we have to convert into the hexadecimal. So here the base is the 16. Okay. So the first step is we write down the given number, but before that we make 3 columns here without line. Here is division. Then second one is result. Third one is remainder. Okay. So we write down the 678. 678. Here we divide it by 16. We divide 678 by 16, and here the result is 42. The remaining is 6. 678 divided by 16. The result is 42. The remainder is equals to 6. Then this 42 is the result. The 42 write down here, and again we divide the 42 by 16. Here we get the result is equals to 2 and the remainder is equals to 10. The 678 we divide by 16. We get the result is equals to 42 and remainder is equals to 6. When the result is obtained, remainder we write down. After that, here this 42 we have to divide by 16 again. So we divide this 42 by 16 and we get here the result is equals to 2 and the remainder is equals to 10. And then the result is 2. What we have to do in the process? We have to divide the given number by 16. we write down the result and record the remainder. We divide the result by 16 till we get the result is equals to 0. Means again we have to divide the result by 16. Here 2 divided by 16 becomes equals to here result 0 and the remainder is equals to 2. Means here only 3 steps we have to follow. First we write down the given number, then we divide it by 16, write down the result and record the remainder. After that here what we do, we write down the result here and divide it by 16. We get the result is 2, remainder is equals to 10. Whatever the result we obtain again, that result we have to divide by 2 until we get the result becomes equals to 0. So here we write down the 0 and here the remainder is equals to 2. We have to take these remainders. We have to write down these remainders in the answer. But how we write down? Recall, we had seen the decimal to binary conversion. In that we given here the arrow. Okay, so here we write down in reverse order in upward direction. It means the first remainder obtained we write down at last and the last remainder obtained we write down at the first. But before writing the answer, we have to convert these numbers because this is in decimal. We have to convert its equivalent, which is in hexadecimal. Okay, so 10's equivalent is the 8. We write down the remainders in the reverse order. Okay, so here the answer becomes, answer is, every time you have to write down the answer with the question. Directly don't write down the answer here like this. Okay, so the answer is 678 base how much? 10 equals to in bracket the given number and here it is 2. Then 10 is 10's equivalent is 8. Then here it is the 6. Base is how much? 16. So 678 in decimal, its equivalent in the hexadecimal is 2a6. Okay, we will see one more example on the same having the integer part. Example is 5, 5, 5, 5. 4 digits are there. The base is 10 and here we have to convert it into the hexadecimal. Okay, so here the steps are again very easy. The same steps we have to follow. First of all, we write down the given number, then we divide it by 16. After that, here what we do, we write down the result and the remainder. Then say third step comes and that third step is we divide the result by 16 until we get the result becomes equals to 0. After each division we record the remainder and after that here when we get the result is equals to 0, then what we do, we write down the remainders in a reverse order. But before writing the remainders in reverse order, check if there is a digit which is greater than 9 in the remainder. If it is greater than 9, then what we do, we convert it into the hexadecimal, such as when the remainder obtained, that remainder is 11. 11's equivalent in the hexadecimal is how much? It is equals to p. If we get the remainder is 15, then here its equivalent of the 15 in hexadecimal is the f. Okay, so here again we make 3 columns. The first one is for division, the second one is for the result and third one is for the remainder. Okay, now we have to convert the 5555. So we write down here 5555. We divide it by 16 and then we get the result is equals to 347. 5, 5, 5, 5. We divide by 16. We get the result is equal to 347 with the remainder of 3. We divide again. This result 347. 347 by 16. We get the result is 21 and the remainder is equals to 11. Then again we divide this 21. It is result. We have to make the division until we get the result becomes equals to 0. Okay. So 21 we write down here and divide it by 16. So we get the result is equals to 1 and remainder is equals to 5. Then we divide this 1 which is again result by 16. Now what we get? The result becomes equals to 0 here. Result is equals to 0 and the remainder is now equals to 1. Now we get the remainders here. What we do? We write down the remainders in a reverse order. But before that we have to check if there is a greater digit than the 9 means greater number than the 9 we have to convert it into the hexadecimal one. So here is the 11 and 11's equivalent in hexadecimal is how much? It is equals to P. Now we can write down these remainders in the reverse order. So here the 5, 5, 5, 5, 5,555 base 10 equals to how much? It is equals to 1, 5, B, 3. It is 1, 5, B, 3. Base we have to write down. But what is the base of hexadecimal? The base of hexadecimal we write down as a 60. Okay. So this is the conversion of the decimal into the hexadecimal. But this method we have to follow only for the integer part. We have to follow it for only the integer part. For fractional part we have to multiply by 16. We will see one example on the fractional part. Okay. Now for fractional part we have to follow the other process and that process is the same as we converted the fractional decimal number into the binary Okay. So what is the process? These steps are very simple. What are those steps? Those steps are same as that of the decimal to binary of a fractional part, but only one change here. In decimal to binary, what we did? We multiply the given fractional number by 2. What we have to do here? We have to multiply the given decimal fractional number by 16. This is only change. Okay. So here the first step is we write down the given decimal fractional number. We write down the given decimal fractional number. What we do after this? Then we multiply the fractional decimal number by 16. We write down the remainder, the result, and we record the carry in integer position. What is the meaning of recording a carry in integer position? For an example, suppose we make the multiplication and after multiplication if there is a result which is 10.2. The result is 10.2. Then here from this 10 we record as a carry in integer position. This 10 we record as a carry in integer position. So the first step is we write down the given fractional decimal number. After that, what we do? We multiply the given fractional decimal number by 16. Then we write down the result and record the carry in integer position. Whatever the remaining part is there, after taking the carry in integer position, we multiply it again by 16 until we get the result becomes equals to 0. Means first step is we have to multiply the given fractional number by 2. Then the second step comes. We have to write down the result and we record the carry in integer position. Whatever the remaining part is there, that remaining part is now we consider as a result. That result we have to multiply again by 16. Again we record the carry in integer position after writing the result. This process we have to follow until we get the result is equals to 0. Now, one thing we have to keep in mind while converting the fractional number into the hexadecimal fractional number, we don't get the exact answer. We don't get the absolute answer if the result is not equal to 0. Then how many steps we have to do? We have to stop after at least 3 steps or we get the recurring answer. What is the meaning of recurring answer? Recurring means if we multiply 0.2, then we get the result is equals to 10.2, whatever it is. We get the result equals to 10.2. Here, the 10 is the carry. We record in integer position. Remaining part is now 0.2. Now, see, here already we multiplied by 0.2. We get the result is again same. So, after again multiplication of 0.2, we get the same result. This is we call a recurring answer. So, we stop when we get the result equals to 0 or after 3 digits we get or when we get the recurring answer. Okay. So, we take one example and while solving the example we see the all steps. Okay. So, example is 0.95 base 10. We have to convert this into the hexadecimal. 0.95 we have to convert into the hexadecimal. So again the same columns we have to make without line. Here instead of division what we do? We do multiplication. So here we write down multiplication. Then next step is next column is for the result. We have to make the bigger column for the result and here the carry octal. The multiplication of what? Multiplication of given fractional number. So here 0.95 we have to multiply by 16. After multiplication we have to write down the result and here the result obtained is 15.2. The result is 15.2. When we do the multiplication of 0.95 by 16, we get this 15.2. Now, from this 15.2, what we have to take as a carry? We have to take this 15 as a carry and we write down the carry here in integer position. Okay. Now, the remaining part is 0.2. So, here is the result. That is 0.2. Now, the next step comes. We have to multiply the result by 2. We have to multiply the result, we have to multiply the result by 16, not by 2. Here we are going to convert the decimal to hexadecimal. Okay. So, the 0.2 we write down here. We multiply 0.2 by 16. The result we get, that result is 3.2. The result is 3.2. Now, this 3 we have to take as a carry in integer position. We have to take this 3 as a carry in integer position. Here we write down 3 and the remaining part is again here 0.2. Now see, whatever the number of steps we do again, we get the same answer. This is we call recurring. So here again we write down once this 0.2 multiplied by 16. Again we get the result 3.2 equals to again 0.2, and this 3 is taken as a carry. Okay. Now we got the carries here. Now these carries we have to write down in the answer. But how we can take the carries? We take the carry in the downward direction. Okay. But before writing the answer, we have to convert these digits which are greater than 9 into the hexadecimal one. So the equivalent of this 15 in hexadecimal is F. So the answer becomes 0.95 base 10 equals to, in bracket, 0. Don't forget to give the fractional point. Okay. So here it is F33. Base is how much? Base is the 16. The answer is 0.33. Base is 16. Okay. One more example we will see. Now we will see the example which consists of both the fractional part as well as the integer part. Okay. What the example is? The example is 148.63. Base is 10. We have to convert this into the hexadecimal. Okay. So here we have to convert the decimal number, but this decimal number having both the parts, the integer part as well as the fractional part. Now how we convert? Like we converted the decimal number into the binary. Here the same we have to follow. The steps are same. We have to divide it in two parts. So first we convert the integer part, and after that we convert the fractional part. So here we convert first the integer. So we write down here integer part. Okay. Then we make the three columns. First one is for division, second one is for result, and third one is for the remainder. Here we make the division, and here is the result. The next one is remainder. Okay. So 148 is the integer part. We divide it by 16. 148 divided by 16. Here the result is 9. Remainder is how much? It is 4. Then 9 we divide by 16. What we get after division of 9? What we get here? The result is equals to 0, and the remainder is equals to 9. Now, if any new steps are there? No. Here we have to stop the conversion because the result is equals to 0. Then we get the result, and that result, we get the answer, and that answer is 94. So write down here 148 base 10 equals to 94. We have to write down the remainder in the reverse order, in upward order. The last remainder of 10 we write down first, and the next one, the first one we write down at the last. Here is the 16. There is 148 base 10 equals to, in bracket, we got the answer 94. Base is 16. Okay. So here we solve the fractional part. The fractional part is 0.83. What we do? We again make three columns here. So first column is for multiplication, second column is for result, and third column is for writing the carry. Okay. So we have to write down 0.63 here. 0.63. We have to multiply this 0.63 by 16. So here 0.63 multiplied by 16. Then we write down the result and we record the carry in integer position. 0.63 multiplied by 16 equals to 10.08. It is 10.08. Now, these 10 we have to write down as a carry in integer position. Then remaining, whatever the remaining part will consider as a result. So equals to 0.08. This is the result now. So 0.08 we multiply by 16, then we get the result. The multiplication of these two is the result. So result is 1.28. This one we write down here, and 0.28 is our remaining result. Okay, 0.28 we again multiply by 16, then we get 4.48 equals to here 0.48, and now the 4 is a carry. Okay, so here these three steps are sufficient because we get the approximate answer. To get the absolute answer, to get the exact answer, what we have to do? We have to follow these steps until we get the result becomes equals to 0. So we stop here the calculations and we write down the carries in the answer. But remember, when we write down the carries, if there is a digit which is greater than 9, then we have to convert it into the decimal 1. Okay, so here the 10's equivalent in the hexadecimal is equals to A. And how we write down? We write down in downward direction. First carry of 10 we write down first, and second carry of 10 we write down at the next one. Okay, so here the 0. How much? 63 base 10 equals to how much? Here it is 0.A14, base is 16. Now we can write down the complete answer, means combination of both integer part and the fractional part. So here is the answer. We write down first, answer is in bracket 148.63. 148.63 base 10 equals to, first we write down equivalent of 148, that is 94 point. Here then the equivalent of 0.63, which is A14, base is the 60. Okay, so this is the conversion of 148.63, which is in the decimal. We converted it into the hexadecimal. Okay, I think these 3-4 examples are sufficient. We next time we will see the other conversion, but for that you have to solve some more examples. You take your own example, go through step by step. If these examples are not sufficient for you, next time we will see the hexadecimal to decimal conversion, and that is also easy.